Sorry about that. Let's go ahead and finish up this problem now. We talked about taking these first two equations and eliminating the a's and the c's in this case. So if I go ahead and multiply by -1 on my first equation, I end up with a negative a plus b minus c equals 1. My second equation I'm going to leave alone. A plus b plus c is going to equal 3. Notice my a's and my c's cancel. I end up with 2b equals 4, or b equals 2. Since b is going to equal 2, I can go and replace all my b's values now with 2. Really, we're only interested in the other two equations, or two other equations, so I'm going to stick with my second and my third equation and let b equal 2. So I know that a plus 2 plus c has to equal 3. And 4a plus 2b, which is 2 times 2, gives me 4 plus c is going to equal 8. I'm going to go ahead and simplify this. Subtract my 2 over, and in this case, subtract my 4 over. So a plus c is going to equal 1, and 4a plus c is going to equal 4. Now I can go ahead, multiply one of my equations by -1 to eliminate my c values. So I know that negative a minus c has to equal -1. I can go ahead and add to my other equation. So 3a, my c's cancel, equals 3, and a is going to equal 1. So now I know my a value is 1, my b value is 2. I can solve for my c value, because I know that a plus c has to equal 1. A is going to equal 1. So we know that 1 plus c equals 1, or c is going to equal 0. So my equation, y is going to equal my a, which is 1, x squared, plus my b, which is 2, times x, plus c, which is 0. So that would be a nice equation. I could clean this up a little bit to say y equals x squared plus 2x. So today, we've learned what a quadratic function looks like, the quadratic term, the linear term, the constant. We've identified the vertex and axis of symmetry, and we've been able to write the equation given 3 points.